Hi everyone. So in this video we will be learning about mapping line features based on a quantitative type of map. So again, in our previous video we reviewed point features such as dot maps and proportional symbol maps, but now we're going to see how do we map line features based on showing the quantity or magnitude of a specific phenomenon. So to map line features, these types of maps are called flow maps. Flow maps use variations in line width or color to show the direction and amount of movement, as well as the types of goods or services moved. The advantages of flow maps is that they reduce visual clutter and they show movement. The disadvantages is that it shows possible overgeneralization. So again, let's look at examples of flow maps. So here, this is an example of a flow map showing us the volume of slave trade between 1700s and 1870. We can see that the size of the arrow, so the thicker the arrow, the larger the volume of slave trade, whereas the thinner the arrow, the smaller the volume of slave trade. Here again, I already showed this as an example of line features for a qualitative map, but we could adjust this map and make it quantitative by changing the arrows to show us the volume of the diffusion of the HIV-1 virus or the quantity of the HIV-1 virus as it diffused to these different continents. This is another example of a flow map. This shows us the top 20 countries of international born players in the English Premier League of 2004. So again, the width of the arrows that we see here from being very thin to a thick arrow shows how many number of international players were there in each country. Next, we'll be looking at mapping area features. So these area features include choropleth maps, isorhythmic maps, and cartograms. So especially for this GIS class, we will be making a lot of choropleth maps. So choropleth maps are most widely used as a thematic mapping technique. So each enumeration unit is given a specific saturation, texture, or lightness depending on its magnitude. The advantages of a choropleth map is that it's easy to understand and they are widely used. The disadvantages are based on data classification. This implies even distribution. Also, we have a modifiable areal unit problem as well as ecological fallacy. So here, this is heart disease in white males. We are seeing two different color schemes. And based on this color scheme, we could see that there is a higher percentage of white males having heart disease on the eastern part of the United States compared to the western part. So for a modifiable areal unit problem, also known as MOP for short, occurs when point-based measures of spatial phenomena are aggregated into districts resulting summary values are influenced by the choice of district boundaries. So for example, I have a base population here and an unemployment count here. And so these first two boxes are showing us two different data sets. And if I show the population as a percentage of unemployed, we could see that if we're using 9 boundaries, that it changes the size of the percentage for the final result. Compared to if we altered the size here, we could see that the percentages or the results are shown differently. And the same for the zoning effect. So this is the scale effect and the zoning effect. A challenge that occurs during the spatial analysis of aggregated data in which the results differ when the same analysis is applied to the same data, but different aggregation schemes are used. MOP takes two forms, the scale effect and the zone effect. So again, we could see with the scale effect, if we're looking at the percentage of unemployed, it looks different based on the different scales, whether it's 9 different boundaries or 3 different boundaries, and the orientation or the way the zoning is applied changes the percentage. So for scale effect, the scale effect exhibits different results when the same analysis is applied to the same data, but changes the scale of the aggregation units. For example, analysis using data aggregated by county will differ from analysis using data aggregated by census tract. Often this difference in results is valid. Each analysis asks a different question because each evaluates data from a different perspective or different scale. So again, we could see with these two maps here that our scale is based on counties and our scale here is based on census tracts. The same data is applied in both of these levels, and we can see that even though it's the same data, that it is shown differently depending on the scale. So for the zone effect is observed when the scale of analysis is fixed, but the shape of the aggregation units is changed. So for example, analysis using data aggregated into 1 mile grid cells will differ from the analysis using 1 mile hexagon cells. The zone effect is a problem because it is an analysis, at least in part, of the aggregation scheme rather than the data itself. So again, the shape of the aggregation unit is changed. For example, instead of 4 rectangles, if you're using 4 triangular areas, our representation or our results are different. So for ecological fallacy, this is usually associated with MOP, occurring when it is inferred that data for study area applies to individuals within a certain area. It is necessary to say that not everything applies to everyone. The assumption that an individual from a specific group or area will exhibit a trait that is predominant in the group as a whole. For example, if we have a state that has an income, so we could say this state has an income from 8,000 to 10,000, and my writing is kind of slow here. 8,000 to 10,000 compared to another state that is right below it, and the population, and the income is from 800 to 1,000 per month. So again, this is 1,000. My drawing or writing with the pen is not really that good. It's saying here that everyone in this box is rich, but that's an ecological fallacy because it could be that only one person has an income of 8,000 to 10,000 per month, and so it's an ecological fallacy to say that everyone in this box is rich. And the same applies here. If we say that everyone in this box makes an income of 800 to 1,000, that is generalizing it, and it could be that really there is one person that is above the poverty line. So that is an example of ecological fallacy. So this is another choropleth map example. This is based on Hispanic origin. And we can see here that dark blue represents 60% or more of Hispanic origin compared to the light pink. The next type of maps are isarithmic maps, and this depict continuous data surfaces by connecting points of selected value with isolines. Isolines are lines, the connecting points of equal value. So there are different kinds of isolines. There are isobars, which show us lines of equal atmospheric pressure, isotherms, which show us lines of equal temperatures, and isoyets, lines of equal precipitation. So this uses a process of interpolation to determine values of intermediate points. And the types of maps that we tend to see that are isarithmic are rainfall maps, topography maps, and barometric pressure maps. So these types of maps are commonly seen in the Weather Channel, especially if we're looking at pressure and temperature and precipitation. So here is an example of an isoline map showing us the total precipitation in inches. This is another example of an isarithmic map. This is showing us the isotope oxygen 18, which occurs in different concentrations. This is showing us the average annual hours of sunshine. So we could see that each point on this line here, this isoline, is that each point on this line is showing us that it is 2,600. These locations receive 2,600 average annual hours of sunshine. The next type of maps that we will be looking at are cartograms, and this distorts the geographical size of enumeration units in proportion to the magnitude of the variable you're mapping. So for example, the size of a state proportional to population rather than the area. So the advantages is that it gives us a shock and it's exaggerating, whereas the disadvantages is that there are distortions and it implies even distribution. So here is a cartogram of the electoral vote in the 2004 election. Here, this is a cartogram showing us county size, and the county size is rescaled according to their population. So again, we see distortion here in this type of map. Also, this type of map is showing us the levels of GDP. So we could see China and United States and Japan have high GDP compared to Africa, which has low GDP. So there are multivariate maps. These show magnitude variations for more than one theme. And these multivariate point symbols can be represented as pie charts or bar charts. Also, there are Chernoff faces, and Chernoff faces are different data dimensions mapped to different facial features. So again, this is an example of a Chernoff face map. This is based on life in Los Angeles, and we could see here with the legend that the facial features represents four different data sets. So we have the affluence based on the shape of the face, the unemployment rate based on if it's the face is smiling or sad, and we have urban stresses based on the eyes and eyebrows, and the proportion of the white population where the color scheme is high, that is yellow, and brown, dark brown, that it's low. So we could see based here on this map in this part of LA, we could see that they have low affluence, the unemployment rate is high, and based on the eyes, it looks like they have high urban stressors, and there is a low white population proportion here compared to the northern part of LA City. So again, there are other examples of multivariate maps. Like we could see here, this is the population statistics in Eastern Europe. The colors show, the different colored blues show the people per square kilometer. And we could see that the age distribution is shown as a pie chart in each location. Also here, this is for the softwood growing stock by ownership class. You could see that the different grayscale palette is shown here in the pie chart, showing us if it's a national forest or forest industry. So again, there are many different types of thematic mapping techniques that we just reviewed. Again, we went over choropleth mapping, isopleth mapping, which is showing us, in this case, contour lines. And we have proportional symbols and dot point analysis. Dot density, I mean. So another type of maps are reference maps, and reference maps focus on geographic locations and features such as forests, roads, political boundaries. Reference maps shows where something is in space, whereas thematic maps tells a story about that place. So again, we just went over thematic maps. Now we're going to be looking at reference maps. This is a reference map example. Also, topographic maps are reference maps. This is from USGS in 1879. It's showing us the roads and the buildings here. And this was a primary civilian mapping agency in the United States. And again, this is a 1 to 24,000 equals 7.5 minute maps. Also, there is a legend with these reference maps. For example, this is showing us the different types of boundaries and coastal features for this type of reference map. Lastly, I want to review historical maps. Historical maps, the study of historical maps is useful for understanding past knowledge and beliefs. Again, we're looking at the historical perception of people and what the landscape looked like to these people. So here, this is a map from the ancient period of 4000 to 200 AD. And this is also a historical map. This is a town plan from Catalhuyuk, which from 6200 BC. This is a clay tablet map from Gasur. This is 2500 BC. So again, we're looking at ancient periods from 4000 BC to 200 AD. This is a world map according to Eratosthenes in 220 BC. This is the father of systematic geography and the Earth circumference and geodesy. Also, this is the reconstruction of the world map according to Strabo, and he's known as the father of regional geography. And this is the Ptolemy's modified spherical projection in 1561. Also, we have a map here in Venice. And here, this is showing us the countries in the Southwestern Sea from the Kwangyu 2. This is showing us Southern Asia and Africa. Also, this is another historical map that we see here in the late medieval period. And in the Renaissance period, we see this is the Mercator's famous world map in 1569. This is the first known use of the Mercator projection on a world map. And also, this is fire insurance maps, also known as Sanborn maps. So that's it for our lecture today. Thank you for watching.